Hello, and welcome to yet another episode of the Secunia Researchcast, our quarterly security webcast. I'm Chaitanya Sharma, and I'll be your host for this Researchcast. I hope you've enjoyed our previous Researchcasts, and we are sure you'll look forward to more of these in the future. Among other things, we'll discuss some staggering zero days and some facts about some interesting vulnerabilities discovered. With this initiative, the Secunia Research team aims to bring to the viewers the most interesting ongoings of the security industry from the past quarter. The Secunia Research team processes a lot of information from various different sources on an everyday basis, and we use the Researchcasts as a platform to share the information and provide more insight about the vulnerabilities and trends. In each Researchcast, we discuss zero days, evolving trends, and interesting things. We also talk about the most interesting vulnerabilities that were discovered in the past quarter. In this webcast, we'll discuss the vulnerabilities discovered in the third quarter of 2012, that is from July to September. We'll note the trends that evolved during that period. We'll also discuss the zero days and the most interesting vulnerabilities discovered during this period. Finally, we'll talk a bit about Secunia Vulnerability Coordination Reward Program, or SVCLP, which is becoming increasingly popular among security researchers. Like in other things, change is the only constant when it comes to type of vulnerabilities being discovered. From time to time, the type of vulnerabilities that are reported keep varying, which gives rise to the trends we note in this section. We have seen an increase in the number of incidents where compromised source packages are uploaded on the distribution servers. These source packages contain backdoors, which leads to a compromise of the server on which these packages are installed. Most recent of these incidents was acknowledged by phpMyAdmin, where the source package on one of their SourceForge distribution servers was replaced with a package containing a backdoor. The backdoor was a malicious file, and in this case it was a single PHP file called server_sync, which contained an eval construct. The eval construct evaluates or executes data passed to it as PHP code, and this makes it possible for the attackers to execute arbitrary PHP code on the affected servers. phpMyAdmin is a widely used application, and SourceForge acknowledged that around 400 users downloaded the affected package. One of the previous incidents was in Horde Groupware and Horde Application Framework, which contained sophisticated compromised source code disguised as legitimate source code. In this case too, the distribution servers hosting the Horde projects were compromised, and some of the source packages were replaced with packages containing malicious code. With more smartphones coming into the market and smartphones becoming smarter, it is imminent that the security of these devices will be put to test. We have seen an increasing number of reports for smartphones recently. Smartphones have also become a favorite at security conferences like Black Hat, and competitions like Pwn2Own also feature special prizes for researchers who can demonstrate vulnerabilities in smartphones. We recently saw Charlie Miller and researchers from MWR Info Security demonstrate working exploits for NFC-enabled devices. Additionally, at EcoParty, security researcher Ravi Borgaonkar demonstrated a way to break Samsung Galaxy S3 device. The flaw was in the way the phone handled USSD codes. USSD codes are codes that allow a phone to communicate with the service provider's computers. In this specific flaw, certain USSD codes could be triggered via a web browser using the tel URI, and this could lead to the device being bricked. Samsung has reportedly issued patches since to fix the vulnerability. As discussed in our previous Researchcast, a lot of focus is being put on SCADA products to audit them for vulnerabilities. We see reports for these products on a regular basis, and this trend does not seem like one that will change in the near future. Vendors and security researchers are putting in a lot of effort to find and fix vulnerabilities affecting these products. SCADA products are used to monitor and control industrial units, example, water treatment plants, manufacturing units, refineries, etc. Vendors are beginning to understand the need for security in these products as they can wreak some havoc if exploited in a sensitive environment. This quarter saw 4 zero days being reported, 2 of which saw active exploitation in the wild. One of the 0 days was in Java, which resulted into a full sandbox bypass. We'll look into that and other 0 days. Towards the end of August, we saw reports emerging of a 0 day in Java. Upon investigation, we confirmed a vulnerability affecting the latest version of Java was indeed being exploited in the wild. One of the servers hosting the exploits was placed in Taiwan. The vulnerability was in the way the class finder class allowed access to certain restricted classes. Using the find class method, the Sun Toolkit class, which is a restricted class, was accessed and was used to evaluate certain expressions. Then, via a call to the setSecurityManager function, an access control was created with all permissions. This allowed the expression, which should ideally have been restricted, to be executed outside the sandbox. The exploit was 100% reliable and multi-platform, which means it would execute on all platforms running the vulnerable version of Java. In September, we again saw emerging reports for a 0 day being exploited in the wild in Internet Explorer. It has been alleged that this vulnerability was also discovered and exploited by the same group that found the previous Java 0 day. The vulnerability was caused due to a use after free error when handling calls to the exec command method and could be exploited to execute arbitrary code. The Metasploit project was quick to release a Metasploit module soon after vulnerability was discovered. Microsoft issued a rare out-of-band patch for this vulnerability and issued a fix. They also acknowledged that the vulnerability was also being coordinated with them via ZDI. This demonstrates that it's important for the vendors to fix a reported vulnerability soon, as it could also be discovered by other researchers who could exploit it for malicious purposes. This is one of the reasons that in January this year, Secunia Research changed the coordination deadline to 6 months to ensure that vendors issue fixes for reported vulnerabilities soon. In the August Microsoft Patch Tuesday, Microsoft acknowledged fixing a 0 day vulnerability which was being actively exploited in targeted attacks. The vulnerability was in an ActiveX control in the Windows Common Control library, which is bundled in a large number of products. Microsoft had previously acknowledged another vulnerability in this control in April. The vulnerability was a use after free error in the tabstrip ActiveX control and could be exploited to execute arbitrary code. The vulnerability was exploited by sending a malicious ActiveX control embedded within a Word or RTF document. Opening the document would instantiate the vulnerable ActiveX control, leading to a compromise of the system. In August, Adobe acknowledged fixing a 0 day vulnerability affecting Flash Player, which was being exploited in the wild. Adobe also added that the malicious file was distributed via Word documents and the Windows platform was targeted. The vulnerability was an integer overflow error when parsing end table values in CFF fonts embedded within an SWF or Flash file. The exploit placed a malicious DLL file on the system, which was then executed by the run DLL32 process. In this case too, the vulnerability was already being coordinated with Adobe by security researcher Alexander Gavron. Moving on to the next section, which could be argued as the most important part of the ResearchCast. Here, we'll discuss the most interesting vulnerabilities reported in the past quarter. In the last quarter, we saw an astounding number of advisories released by the Zen Hypervisor project. The impact of the vulnerabilities was primarily DOS and privilege escalation, and none of the vulnerabilities was exploitable remotely. In all, we saw 10 advisories being released by them. This does not point to the fact that Zen is insecure, but on the contrary, it shows that they actively track and fix issues reported to them. Vulnerabilities affecting Oracle products are always interesting, and publicly discussed vulnerabilities only raise the level of interest. In Black Hat this year, David Litchfield demonstrated a privilege escalation vulnerability in Oracle database which allows an authenticated user to gain sysdba privileges. The vulnerability is in the ctx.sys.context index, and the problem was an SQL injection vulnerability when handling certain queries. To successfully exploit this vulnerability, an attacker would need to have create table and create procedure privileges and execute privileges on dbms_stats. It was initially unclear if patches were available for all affected versions, which fueled speculation. However, Oracle was quick to clear up that the vulnerability was already fixed in the July update cycle. It's rare to see a vulnerability affecting the GNU-C library. In August, we saw some integer overflow vulnerabilities reported in the library. The vulnerabilities were in some of the stdlib functions, example string to decimal and string to float. The problem was that integer overflow errors existed in these functions when processing large amounts of data and could be exploited to cause stack-based buffer overflows. The important thing about these vulnerabilities was that unlike other vulnerabilities affecting similar products, the vulnerabilities were in the library itself rather than in the applications relying on the library. Code execution could be achieved in context of the application using the vulnerable functions. Via the SVCLP program, we received many vulnerability reports, and a lot of them are interesting to analyze. Francis Provencher reported a vulnerability in Novell GroupWise that affected the GroupWise Internet Agent. An integer overflow error existed in the GroupWise Internet Agent when processing the content length header value. If the request sent contained the header value as -1, this triggered an integer overflow error, and the resultant buffer was smaller than the required value. This resulted into too much data being copied into the buffer, causing a heap-based buffer overflow. The next vulnerability I'll discuss was discovered by the Secunia Research team. The Secunia Research team discovered a vulnerability in the latest version of Adobe Photoshop, that is CS6. Photoshop supports various image formats including TIFF. The TIFF image may be compressed using various algorithms. The problem was when extracting image data from TIFF images compressed using a specific compression scheme. The function responsible for decompressing the data decompressed all rows specified by the image height into the destination buffer without performing any boundary checks. This could be exploited to cause a heap-based buffer overflow by manipulating the image dimensions. Towards the end of September, Adobe issued a notice that their code signing certificate was stolen. The certificate is used to validate that the applications are indeed built by Adobe. However, Adobe noticed two malicious utilities that were signed using a valid certificate, and they were quick to identify the cause and the source of the incident. They stated that one of their built servers, which had access to its code signing infrastructure, was compromised and the code signing certificate was stolen. Attackers with access to the compromised certificate could sign malware with it and make it appear as if it was built by Adobe. Adobe is now in the process of revoking the compromised certificate and states that no end user or administrative action is required to receive the updated certificate revocation list. Now to talk about some interesting vulnerabilities fixed in Microsoft's Patch Tuesday. In their July update, Microsoft fixed a vulnerability in the Windows shell. This was an old school vulnerability, and it was surprising to see this vulnerability in all versions up to and including Windows 7. The problem was that when opening a file or directory in command prompt via the Explorer, the execute normal function did not validate the name of the file or directory. An attacker could create a maliciously named Samba share, which contains some shell commands in the name, and could trick a victim into opening the share via the command prompt here option. This could lead to the command in the share name being executed and could result into a compromise of the victim's system. Although the vulnerability in itself is not highly critical as it requires a fair amount of user interaction, it was still interesting to see that such vulnerabilities still exist. In the August update, Microsoft fixed 4 vulnerabilities affecting the remote administration protocol. One of the vulnerabilities fixed was a format string vulnerability in the print smoother service, which Microsoft stated could be vulnerable on Windows XP and Windows Server 2003 depending on the environment. The server thread function of the local print spooler library had a format string error which could be exploited by sending specially crafted wrap responses and result into arbitrary code execution. Stack-based buffer overflows in most Microsoft products are hard to come by. This was also demonstrated by our Chief Security Specialist Carsten Iram at RVA Sec in June this year, where he discussed code maturity and security development lifecycle. However, there was a dent in Microsoft's armor, and in the August update they fixed a stack-based buffer overflow vulnerability in Visio 2010. Alexander Gavron reported that a boundary error existed when passing mtext strings in the entities section of DXF files. This could be exploited to cause a stack-based buffer overflow resulting into arbitrary code execution. This vulnerability could be the result of an oversight during the STL process, and we hope that more such vulnerabilities are not found. The SVCLP program, as you may know, is a new offering by Secunia which allows vulnerability researchers to coordinate vulnerabilities via Secunia and in return get a chance to win some prizes, including a chance to visit a security conference of their choice, plus a paid hotel stay. We'll be announcing the winners for the year 2012 in December, and this gives you 3 months to find and report some awesome vulnerabilities. Via the SVCRP program, we make the coordination process very interactive by providing detailed feedback and analysis about the vulnerability, which also makes it very interesting for the researchers reporting the issues. This brings us to the end of this quarter's ResearchCast. If you've enjoyed watching the ResearchCast and have some comments or would like to hear about other things, then please do write into us at vuln@secunia.com. Thank you for joining us today. This is Chaitanya Sharma signing off. Goodbye.